All right, today's class we're going to be looking at stoichiometry problems, mole-to-mole stoic problems, probably where you want to start off when you're learning stoichiometry, because mole-to-mole problems are probably considered the easiest type of stoic problems. So before we get into these problems, here's the steps that you want to follow to solve any stoic problem. Always balance the chemical equation first. Before you do anything, go back to your balancing rules and make sure that the amount of products on the left of the equation arrow equal the same amount of atoms as the product side of the arrow. Okay? All right, your second step, you want to establish molar ratios. Once you balance that chemical equation, you want to see your reactant to product ratios and also your reactant to reactant ratios as well. And your products. How do your products match up mole to mole? And then finally, you're going to convert from your given unit. Okay, whatever they throw at you in the problem, moles, grams, molecules, you always want to convert that to moles. And then using your mole to mole ratios from number 2, you want to convert to the desired unit. And I always tell my kids and my students in class, use this formula. Take your given unit and multiply it by your desired unit divided by your given unit, right? Your conversion factor. And this is what the molar ratios are going to allow us to do. The only way, I can't stress this enough, the only way you can compare one substance to a different substance in a chemical equation is mole to mole. That's why we always balance first. All right, keep that in mind. So our first problem that I'd like you to try is right here. Okay. How many moles of aluminum sulfate, Al2 parentheses SO43, are needed to react with 8 moles of HCl? Notice we have aqueous reactants. That's not going to really matter in the problem. It just tells us the state of matter. And from here on out, I'm going to get lazy, and I'm not going to write the states anymore. Okay? But this is unbalanced. I'd like you to try this. Pause the video, and I'm going to show you the solution when you're done. All right, so let's take a look at this. Okay, if I look at my ratios, right now they're 1 to 1 to 1 to 1, but they can't stay that way. Right? So if I balance this, I see here that I have 3 sulfates, and I have 1 sulfate here. So I'm going to put 3 moles of sulfuric acid. Okay, but that changes things a bit. Okay, I see I have 3 chlorides here, and I only have 1 here. Okay, 3 times 2 hydrogens, that's going to get me 6. I'm just going to balance this out. This is going to be a 2. Okay, and that should balance it out. All right, so that's our first step. We're going to balance the chemical equations. Now my ratios have changed. They've got a 1 to 6 to 2 to 3 molar ratio. All right, that changes things. So our solution to this is we're going to balance the chemical equation. Right? So like we did previously, here's our molar ratios. And then secondly, I'm going to convert from my given unit to my desired. So look what they gave us here. This is what they gave us, right? This was our given. 8 moles of HCl. And I'm trying to convert that to moles of aluminum sulfate. The only way I can compare the two substances is their 1 mole to 6 mole ratio. That's where I got this ratio from, the balanced equation. Right? This is from the balanced equation. What's in parentheses here? Okay. So moles of HCl are going to cancel. 8 times 1 is 8, divided by 6. I get 4/3, or 1 1/3, or 1.33 moles of aluminum sulfate. Notice, this is still a 1 to 6 ratio. It never changes. If I multiply 1.33 by 6, I go back to my original, my given amount. All right, so that's the first problem. Check your steps. Okay, we're going to finish up today. Whoops, as I get trampled here. Problem number 2. All right. If we have unlimited aluminum sulfate from the previous problem, if we had unlimited aluminum sulfate were supplied, how many moles of sulfuric acid would be produced from 20.5 moles of hydrochloric acid? Okay? We're using the same equation. As always, try this. Pause the video and we'll go back to it. All right, let's take a look at what you did and see how you match up to my results here. So here's our given information. That's what's given in the problem. And if you notice, it has 3 significant figures. Okay, so that's going to dictate where we cut these numbers off in our final answer. All right? So let's start with that, 20.5 moles of HCl. So we balance the equation as we did previously and use the molar ratios. Here's my given. The only way I can make that jump from hydrochloric acid to sulfuric acid, I'm comparing these two substances here. I compare them mole to mole, right? 6 moles of HCl are needed to make 3 moles of sulfuric acid. Okay, so once again, this is from the balanced equation. All right, so when you're stuck on these types of problems, I see a lot of students, where do I go next? How do I compare HCl to H2SO4? Always go back to your balanced equation. Right? You could also reduce this to 1 to 2. It's going to get you the same answer. Okay, they're just ratios. So 20.5 times 3 is 61.5. Divided by 6, I get 10.25. And to 3 sig figs, the 5 rounds the 2 up to a 3. And this is my final answer. Okay. Once again, notice, this is a 1 to 2 ratio. Just like it is up here. This is a 1 to 2 ratio. All right, guys and girls, as always, good luck on these problems. We're going to do a lot more Stoic. Some of the flip videos that I'm going to make this week are going to get a little bit more involved. Instead of going mole to mole, we're going to start going between grams and moles and molecules and liters. So it's going to get a couple more extra steps involved here. All right. Until next time, good luck, and I'll see you in class.